UTS is a university closest to the heart of Sydney. It's a young and growing university. MAPS is the School of Mathematical and Physical Sciences. The mission of MAPS is to put mathematical and physical sciences at the centre of the technological revolution that's happening in society at the moment. We were put together from departments of mathematics, physics, chemistry and forensic science. So we're quite a multidisciplinary team, but we're quite unified as well. Having the departments together gives us a chance to be at the heart of a technological transformation in society where mathematical, physical and chemical methods are all combining together to a lot of the new technology.
These days, cutting-edge research happens at the intersections between the fields, and there are only few fields which are left where the research is contained within the formal discipline. The main idea behind trying to get information on mechanical properties of cells is that it's potentially very useful to study diseases and how disease modifies cellular conditions. So that's where we are getting potentially that this knowledge and thematical model will be very helpful in predicting the process of disease.
This process is called Brillouin scattering. To actually make sense of the experiment and to sort of make sense of where we should look, how we should look, we need to actually have mathematical models. All of these things are jumbled together and they form an intensely, extremely complicated mathematical problem that we're trying to actually solve to make sense of the experiment.
My background's in applied probability and random processes, so trying to model systems where there's inherent uncertainty or variability. So some of that is in environmental science, looking particularly at the health of coral reefs, particularly the Great Barrier Reef, looking at ways of injury prevention or sort of injury rehabilitation strategies. Some of it's on sort of elite talent development in sports academies, ways of trying to minimise the impact of traffic accidents, ways of actually trying to improve driver safety. So it's that kind of cross-disciplinary collaboration between health scientists, between the human performance scientists, sports scientists, and the mathematics, where they're generating the data, they're generating the interesting problems. And sometimes these things are things whereby some of the mathematical tools of probabilistic modelling or statistical modelling can actually help answer these questions. It's nice to see some sort of impact of what you're doing.
UTS has very strong computing science, and we've got people doing quantum computing, quantum information theory. We're working very closely with the data scientists, and they've got something called the data arena over there, which where you can actually get inside your data in a 3D sense and see the data all around you and actually see patterns that you wouldn't actually normally see. It's quite exciting.
I hope that by providing new computational methods to solve equations that were previously not thought possible to be solved, we can help move science forward.
In forensic science, we deal with large quantity of data, and for investigative and intelligence purposes, statistics can be used to reduce the dimensionality of the data, to cluster or classify data using supervised and unsupervised methods, but also to provide links between different traces or trends over time.
So in forensic science, we also deal a lot with making inferences about events that occurred in the past. So one of the big issues in forensic science is to deal with this uncertainty by applying probability theory. So we assign the value of the evidence to different observations made on a crime scene or traces collected on a crime scene. And this value of the evidence takes the form of a likelihood ratio or Bayes factor. And it's basically the probability of the observations given two different competing propositions.
So I think the School of Mathematical and Physical Science is very important because there is people with different backgrounds that can help us achieve what we want.
We hope to bring mathematics forward. We hope to contribute to education in mathematics, training the new generation, and also in research in mathematics and bringing it to new applications and domains where it can make a contribution that might not have been previously thought of.
The future looks pretty bright for the school. I think that society is undergoing a transformation at the moment, not just in the big data arena and not just in Facebook knowing all our things, but actually big data is studying all our intimate, studying how our gut works, studying how our brain works, studying how our cancer cells grow. This really needs high-level mathematics and physics to make it work. We're placing ourselves right in the nexus of all that.